So for question 1 for this worksheet, we're asked to look at the contains method, which we've seen a couple times so far in this course. Just to recap quickly, remember that the contains method starts with two base cases. One checks if the tree is empty. We can see that that's this first base case here. The second one checks if the item that we're looking for is the value that's in self.root. So this is where we've actually found the value that we're looking for, in which case we can just return true. Then we have two recursive cases. One which looks in the left subtree if the item is less than self.root, and the other which looks in the right subtree if the item is greater than self.root. So remember that the main advantage of this sort of recursion is that we can find our value by only looking in one of the subtrees. We don't actually have to search through the whole tree in order to find out if it's in there or not. We can just look in one subtree or the other subtree. We don't have to look in both. So we've got three examples here, and the question just asks us to go through and circle all of the values that are compared against the item as we're looking through this tree. So let's start with the first one. So the first one, the item that we're looking for is the number 25. So the first thing that's going to happen is we're going to visit the root. We look at the root, and the first thing we see is, well, this is not an empty subtree. So what we can say is we do have to compare the item against self.root. So we'll circle 13 because we're going to compare 13 against 25. We find that 13 is not equal to 25. And in fact, the item is greater than self.root. So we're going to look in the right subtree. We recurse into the right subtree. We say, okay, is 20 equal to 25? No. Is it less than? Yes. So again, we've done the comparison against 20, and we're going to recurse into the right subtree again. Now, we're at a leaf node, but a leaf node is still not empty, so we still will do the comparison. We'll compare 25 against 30, so we will circle that one. And at this point, we have found that it's not in the tree because there's no further children to recurse into, so we're done. This will return false, back up the tree, and our contains method overall will return false. So when we're looking for 25 in this tree, we only have to compare 25 against 1, 2, 3 nodes. Okay, let's do the same thing here, but this time we're going to use the same tree, but we're looking for number 10 instead. So like we saw before, we do have to compare the root of the tree against 10. So we circle 13. Now 10 is less than 13, so we know that we have to recurse into the left subtree. Now this subtree is again not empty, so we do have to compare 10 versus 10. So we'll circle that one as well. But this is actually one of our base cases. This is the case where item is equal to self.root. So in this point we can just return true, in which case we return back to the previous call, and our contains method will return true. So you can see that if we find the value earlier on in the tree, then we actually don't need to keep on recursing down all the way down to the total height of the tree. We can just stop. So in this case, we only actually have to look at two nodes. All right, last but not least, let's do number 13. Sorry, let's do number 3. So this time we're looking for the value 4. I'll go through this one a little bit quicker because we've already done this a bunch of times. So we compare against 13, it's less than 13. So we go into the left subtree, compare against 10, it's less than 10. So circle that, we go into the left subtree again. We compare against 5, we see, okay, 5 is still more than 4, so we recurse into the left subtree again. We compare 3 against 4, and now we have nowhere farther to recurse, so we just return false all the way back up the tree. So in this case, what we've seen is this is the most number of comparisons we've had to make. It's 4. And what we'll find is actually this is the most we'll ever have to make when we're using this contains method, because there's no farther we can go. The height of this tree is 1, 2, 3, 4 nodes. So that's the total number of comparisons that we're ever going to have to do.